First of all, I don't know if you're familiar with what is Innovafeed. So Innovafeed is the first company that produce insect flour and oil. And we have at Innovafeed few missions. First is to prepare the feed of tomorrow, which is one of our key drivers. We want to reduce also the dependency with other protein source that's from soy, for example, and be independent by producing locally some alternatives on proteins. We want also to protect the planet, for sure. That's one of the key drivers. And we want also to be sure about the quality of ingredients that we use for this production and deliver to the insects to recenter their role on the nature. One of our key elements in our process is industrial symbiosis. Every factory model that we want to produce and build on Innovafeed must respect this model. Few things. We produce finished goods like proteins and insect flour for aquaculture and pet food. We produce also some oil that is used for chicken, porks, to provide them fats and combine with their standard feed. And we produce also frass, and what is the frass is all the dejection from the larvae that are reused and transformed to produce to agriculture some fertilizers. And these circular elements provide us some feed for our larvae. And we have also a partner in NEL, it's Cogeban, that provide us some green energy in order to ensure electricity, the appropriate temperature on site, because our fly is very specific and need temperature and humidity. And that's the ecosystem we built and we want to maintain and improve. Okay? And based on this concept of company, we are producing some flour and products. But to operate this, first I want to present you the history of what we have done. So Innovafeed was founded in 2016. Okay, and to start, we use with basic tools like Zoho, like Google Sheets in order to operate. So that's, I would say, the introduction of the concept. And in the next 2-3 years, we built some different verticals. First one about the data. Okay, so data capitalization, data storage. That was the driver of information and how we store and analyze performance, way of improvements. And it was a 2-year project that is now continuing, evolving with the other solution we developed. And we have also the WinCC, all the SCADA, the supervision, to drive the machine and build something that is completely normalized and ready to host interface with other systems in a standard way and unique way for all the machines. After this period, we enter in I would say, a gray zone, that's kind of gray, where we need to build a solution like MES MOM without any real expertise on it. So we try different solutions. The Power Apps platform that was in between big monolithics and say custom developments, and also another custom developments. And finally, both of them were not exactly what we needed because of this new process, evolution on daily basis almost. And that's the moment we try to identify the next future MES. And I guess that's you know who it is. This is Tulip. To determine which platform fit the most with our requirements, we create a kind of benchmark where we compare some MOM monolithics, okay, some no-code platform, some low-code platform, okay, and also custom dev. So we compare all of them. We identify a few editors. We try to challenge a little bit pros and cons. And to create the criteria to determine which one is the most appropriate for us, we wanted something that is completely flexible. Flexible because our process changes every week or almost. And we wanted to have a platform that is flexible enough to be able to change the execution flow pretty fast and with autonomy. We wanted also something robust enough for the ambition of Innovafeed to grow and to replicate the model. We wanted something with a capability of scalability that is important at this stage. And respecting our IP, because IP insect farms is new. We develop every specificities, and our competitors are their own. We have our own. We share sometimes some elements, but key drivers in the performance must remain secrets and our property. And of course, the cost is important because definitely we are not a $1 billion company yet. I hope so. And we need also to produce things fast. Perfect from the first time, probably not. But we try, we fail, we retry, and finally that's the key of success. And to provide to build this platform and this set of solutions, our approach was to say everything that can change frequently must be defined on this no-code platform to give the backbone and rework this backbone as many times as we need. We wanted also to put the user in the middle, I would say, in front of this solution, to build their own equipment, to build their own, I would say, environment of work, and to create with this user experience to adopt the solution, the platform, and make sure that they will use it, not because we force him to use, but because it's its own creation. Okay. And we combine a lot of other elements in terms of new needs, in terms of limitation of custom development that doesn't give us the flexibility we need or create the dependency with system integrator. That's also part of the decision we have decided. And based on all the scope of definition, we have selected Tulip. With Tulip, we started in different phases. First one, we had the demo first to present a complex process that was definitely a first contact challenging, but that can demonstrate the efficiency of the platform, the efficiency of the accelerators, the visual aspect of the apps built in few days. That was very, very positive in terms of feedback. And after that, it was the opportunity for us to build a strong partnership with the editor. First, because we are new, we'll have a lot of requirements, a lot of, I would say, weird requests, but with the ambition to make it work fast, replicated, and efficient in terms of performance. And for that, we build our own expertise to avoid this dependency with other integrators. So we run into a POV approach where we developed, with the support of a professional services team of Tulip, a set of apps and with dedicated, let's say, complex and technical aspects to profile without any technical skills. Okay? We had a process engineer that developed the integration with SCADA, just to capture a barcode reader and define the next station to operate. And all these business cases were a preparation for us to to discuss and start discussion about what we call NEL 3. NEL 3 is our automated shop floor. We'll see more details in next slides. And we wanted also to have something that is, in terms of OPEX, control and for the coming years, because the development will continue every day. Now the project has started. And to start this project, we were the only entity in Innovafeed that used the Agile approach. Why Agile instead of waterfall? Because of this flexibility, because it fits with the product logic and implementation. So we decided to run 2 weeks sprints with priority set first on the target solution that we wanted to implement. So we used the initial design and we phased them. We wanted to involve contributors every 2 weeks on what we deliver. Do you approve? Do you have comment, feedback? What would be the next one? And that's how we operate during this Agile project. And at the same time, during realization, we had, I would say, 2 streams. First one is the transition to prepare the future and the automation. For one big important element is that we prepared the solution for a building that was under construction. So we cannot test in real case. The building is not ready. We're not allowed to enter in it. We don't have the machines, so we need to simulate a lot of things. That's why the concept of one team and one entity to develop, discuss, and take decisions all together is absolutely necessary. And we validated this approach with a set of meetings that were prepared to show what we have done, to collect immediate feedback from the user. So they will be the end users. So they have to decide and present what they need and what they challenge what we propose. And be reactive in this modification adjustments. And we present the evolution 2 weeks, 1 week or 2 weeks later. So they were very impressed with the reactivity of the platform and the developer associated. But as we started using this platform, we also discovered technical aspects, best practices that need to be defined as the basis of our development. So the other stream consists in defining best practices in terms of naming convention, ergonomics, integration with other systems to be sure that it's flexible enough, we can replicate them easily. And after all these 2 streams, we result into an end-to-end flow simulation. This end-to-end flow started with some systems that have backups and dev environments, and the SCADA for us that were simulated in a different way because we don't have any development SCADA. Okay. Our assets were distributed in different shop floors that were candidates to use Tulip. The first one is the egg production. For us, the egg production is the moment we get flies and we collect the eggs, and that's very manual, so something that we can put in production very fast. We can improve based on experience. The larva production is the automated shop floor that we have that we discussed earlier, and it consists in declaring the production, preparing the container, manage some transport order to deliver the container at the right moment at the right place, and integrate some quality aspects to validate the conformity, the maturity of the larva in order to declare them good or scrap and continue the life cycle of this larva. On R&D, they wanted to have some elements to control their use case by executing processes, collecting some data, and compare this data with, I will not say golden batch because this is not golden batch, but a reference production order and reference performance. and decide whether a feed recipe that changed is more efficient than the standard one, and or change the delay of larva during night period versus day period. A lot of parameters that were integrated. And processing, that was candidate for one big reason. First, the harmony of the unique software for the user, but also and mainly the replacement of this former solution, Power Apps, which require a lot of external resources to improve the solutions. Okay. In terms of modules, we cover inventory management, quality, machine integration, and integration with PLC for sensors. But once again, main objective was to operate our larva shop floor with automation. So that's why we contributed into a set of mainstreams for automation that we develop step by step. And before going in details in this automation we implemented, just want to share a little bit the architecture and how it is integrated in our IT landscape. So, as I told you, we created all the machine and the supervision with a unique, I would say, Innovafeed supervision that exchange with different other SCADA or directly with the machines. Objective is to have something centralized with the best practice of naming, and it's not unified name model, but I would say a kind of equivalence internally. And everything in terms of reporting was centralized around Snowflake and Power BI. That is the reference for long-term analysis, but also operator analysis. That's how we implemented this reporting solution in the past. And we changed a little bit this position later on with a unique data set. In terms of WCS, as we are using conveyor to move our pallets that pretty heavy, sometimes more than a ton each, we wanted to be connected with a system that gives us the possibility to execute a transport from point A to point B. And in our former shop floor, this WCS was extended to a more complex feature, including WMS, which is completely out of his expertise. So we twist the solution, and we have seen a lot of defects, a lot of cons of this approach that we wanted to change by the implementation of our mom platform, which is Tulip, to integrate and operate all the transactions integrated directly with the different systems. Okay. With automation, our objective, once again, was to prepare this revolution, but we do not change everything in one day. When we started the discussion about evolution, we knew exactly which system we're supposed to connect, to exchange, which protocol that we knew because we normalized them in advance. But what was critical for us is to be sure that the day we start the new workshop, the new shop floor with this automation, it works. And at this stage, automation were as beta solution. So it was a big risk for us. And we decided to work in parallel with the former solution of automation, that is the headless, and manual operation as well, to be sure that operator, if they process the action manually, will respect the same way of execution. So that's this parallel definition and this parallel development of manual semi-manual and automation was absolutely necessary to minimize the risk. We were very lucky that at the end, automation was 100% operational from day one. So we would be able to start efficiently this shop floor with automation, and we continue to improve it every day. To make it work, the tool is not enough. We need to involve the right person at the right moment and take the right decision. And as I told you, we were all working the same way to succeed. And to succeed, everyone is involved, everyone is committed. And that's why we discuss daily basis with automation team in Innovafeed, business, mom team, and also in the context of our partnership with the Tulip product team to highlight elements or best practice on how we want to implement this kind of logic. What is the best practice? How to proceed? And by exchange and proposing different solutions, we co-built this automation with product team. And that's the case, for example, of expression. Expression was not available at the beginning. Some different feature, the loops, the call to the connectors. And step by step, we build and enhance this automation capability. And with this one team organization, we contribute in creating our own best practice as well. Some best practice came from product team saying, okay, we have a limitation at this stage. That's the recommendation, and that's the standard way to bypass this limitation and secure your execution. We implemented a lot of automation with this rule. For loops, we started with something else, so that we process a lot of connectors in a row, longer in terms of execution. But once the looper arrives, that's changed, and we replace the best practice by a new one with new feature and more efficient. And globally, this way of working shows us that we can do almost everything. We can change very fast every process, every decision, every result. And that's a big success because today we operate our shop floor with all the work center 100% automated. The only human contribution on this is the trigger the moment we decide to move a pallet, and that's just the trigger that the operator decides to press. Once they press the button, the rest of the process is 100% automated. Mean that creating the transport order, creating, defining the solution, the destination to move, register the weight of the container as soon as you move on a scale, changing the destination based on occupation on work center A or work center B. Both have the same capability, so we just balance the workload. And we send the instruction to the SCADA. A lot of combinations are possible, and everything is possible thanks to this automation and this big, I would say, work we have done around this topic. And to give you a few examples, because we started step by step, so that's the logo of Innovafeed that I tried to reproduce, and that's starting with something simple. It was the result in real time of the weigh. So we have RFID that are used to collect the eggs. They drop the collectors on a scale with RFID reader. It sends to Tulip the information about the weigh, the list of ID tags from the collectors, the scale that is used, and then the automation capture the tags, get the tar of each collector, calculate the net weight, and register the netway against the order and operation and the cage where this collector were issued from. The second case is the transportation order. So we have, that's the big containers. So just to illustrate what this container is, that's 3 stacks and 3 piles of 6 containers, 6 trays. That is something high like this approximately. And we store in this product some substrate, pretty heavy because the density is important because that's the feed for the larva, plus the larva inside. And we have a 3-floor production, 10 floor of storage with 1,000 locations to store these pallets on each floor. So it's something like 10,000 location aisles to store the containers. Everything is automated. We execute order from point A to point B with a strategy to put away that is executed at every checkpoints, depending if we need to change the destination or confirm destination. And last one, I would say it's the most complex automation execution. And in fact, this is multiple automation executed in a row. That's the moment the container arrives empty. We end the transport order once the pallet arrives to the machine. We send the instruction to the SCADA to start the sequence of injection to introduce the substrate, inoculation to introduce the larva. And once the sequence is over, we receive the answer that process is over. We create a new transport order, move the pallet from one step, weigh the pallets, create a new order, transportation order, calling the put-away strategy to determine the best location, and let the WCS operate in moving this container to the destination. That's use case that we have implemented, and today we are using 16 million tasks a month. I don't have much video or photo to share, but that's the fly we are producing. Follow the fly, check this QR code, and you will see the video showcase that we've made last year about what we have done. Any question?
That was very interesting, thanks. I think that's probably one of the most advanced uses of Tulip I've seen, I think. We were talking at lunch, actually, weren't we?
Yeah, absolutely.
But it's very impressive to see it. I'm just wondering, as you started with automation so early, how robust were they? Have you had any issues at all? Any sort of drop tasks and things like that, or performance issues?
In fact, automation is more a way to orchestrate the actions. In case of failure, it means that the SCADA or the WMS will pop an error, an alert, and we centralize the alerting system. So operator has a red light that pops up somewhere and knows that something goes wrong. So it's not the execution itself that we monitor, because each system has its own elements to highlight defects. But the way we confirm, we trigger the action, we accept that it started. After, that's the other system that managed the error. That's the way we centralize that. And as far as I remember, we do not have much defects on automation itself. First, because we secure the data, because if one information is missing at this moment, that's a risk to fail an automation because one parameter is missing. So we anticipate this control. And during execution, we have a result that the automation is completed. So that's a way to confirm that it's over.
And are you doing a lot of BI stuff on Snowflake with all of that data?
BI, why we kept this Snowflake and BI logic is that first it's historical solution that we use, and we have a lot of, I don't know how millions of information are stored in Snowflake, but it's huge. What we have done is we split it, the responsibility of reporting, in two parts. First is the long-term analysis. Long-term analysis is not responsibility of Tulip. This is more a BI, and we can articulate a lot of parameters coming from sensor, coming from automations, coming from WCS, whatever. This one stays in Power BI and Snowflake. What we have done is we anticipate the alerting, the reporting for operator, for immediate decision in Tulip. And we wanted in Snowflake to remove these reports to avoid the situation where users are comparing two values. And as we have 3 hours delay to collect the data from Tulip to Snowflake, they compare, not apple to apple, but they compare different things, different set of data. That is the reason why we have gaps. So immediate decision, Tulip, long-term decision analysis, Power BI.
I got one more question, if that's all right, actually. Because some of Tulip's reporting is obviously, it's not really designed for doing reporting. Do you do any type of formatted reporting, or do you use another tool? Do you have anything connected to it, or do you do it on Snowflake, anything like that?
In fact, what we need in terms of reporting in Tulip is first to highlight a defect. It's just more a warning by display a number, display an evolution or a trend over the working hours. And if you want more details, have different apps to focus on what's going wrong.
All right. That's the end of the session. So we'll give Thomas a round of applause for his presentation.
Thank you very much.